Assalamu alaikum students, welcome to our channel. Today we are here for our new video. In this video we will discuss how we deal with the chapter that's differentiation. Let's start with this topic. I have different questions for you. Let's discuss one by one each question and how this concept goes on. As you can see in the question number one, find the value of dy upon dx. Dy upon dx, just the, remember dy upon dx. Yes, when we listen this word, when we hear this word, so dy over dx can also be written as sometimes in the different book it calls differentiate with respect to x. Sometimes they use this word, this statement, instead of writing dy upon dx. They say find differentiate with respect to x. W R T X with respect to x. So we have to differentiate the equation of the curve. Let's see how it works. Okay, erase this part. It's part of a differentiation. Different questions I have for you. Starting with the first one, there are to differentiate. So dy upon dx, this symbol tells me that I am start differentiation the equation. Now, how do I differentiate? Let's go in detail. We have x squared. The first thing first, we bring this power down, subtract 1 from the power. Similarly, we go for the next term. As you can see, we have power 1, so we multiply by 1, subtract 1 from the power. The last thing is a coefficient, is a constant with no x, means x power 0. So whenever we differentiate any constant, the derivative becomes 0. Now simplify the terms. So dy upon dx will be, it's 2x plus x power 0. And you remember anything with power 0 always equals to 1. So dy over dx will be 2x plus 1. Now, since I'm looking for the gradient or the value of the dy upon dx, which is also called the gradient or gradient of the curve or gradient of the tangent, so we substitute the value of x. We substitute the value of x in this dy upon dx to get the value of the 2 times 2 plus 1. So your final result will be dy over dx is equals to 5. Remember, dy upon dx can also be labeled as the gradient of the curve or gradient of the tangent. Okay, let's move for the next question. Question number one, part B. Let's see what it says. Same thing, yes, differentiate the equation and then substitute the value of x. But as you can see in this question, we found something different and we found an x in the denominator. So before differentiation, your x should be in numerator. Let's go for it. As I do, bring in the numerator, the power changes its sign. Plus 1 becomes minus 1. Let's start differentiation, follow the rules. First thing first, 5. It's a constant, no x. Therefore, the derivative becomes 0. In the second part, I bring the power minus 1 down and then subtract 1 from the power. Okay, so dy over dx will be, it's 2x power minus 2. Although it's not wrong, but it's better to make powers positive. So dy over dx is going to be 2 over x squared. Let's bring it back to the denominator. Now, since I'm looking for the value of dy upon dx, substitute x as 2 in this derivative. The 2 over 2 squared. So dy over dx is 2 over 4. So your final answer will be dy over dx is equals to 1 over 2. This is the value of the dy upon dx. So in this question, very important thing we learned that for the differentiation, every x should be in numerator. That's the important point we must remember. Okay, let's go for the next part. That's part C. Yes, one more thing that we have to learn from this question is, as you can see, we have a single fraction. So your term should be in different fractions. How can we break the fraction? Let's see. First thing first, we will break the fractions. So y is equals to how? So this x square belongs to each numerator and this becomes the denominator of each numerator. This is the way we break the LCM. Let's simplify. As you can see, the power of x is 1 here. So the two bases are same, powers are subtracted. It's going to be 3x to the power minus 1. Look at the second term, x should be in numerator, therefore it becomes x to the power minus 2. Now the time has come to differentiate the equation. Yes, dy over dx. So first bring down this power and subtract 1 from the power. Same will be applied on the second term as well. Bring down the power and subtract 1 from the power. So dy over dx will be negative 3x power negative 2 plus 4 power negative 3. Again, same suggestion, same request. Yes, make the powers positive. Bring it down, changing its position. This is what we have, that first derivative dy upon dx. But since I'm looking for the value of the dy upon dx, and I'm going to substitute the value of x, which is negative 2. So dy over dx is equals to minus 3 minus 2 square. Now let's calculate, simplify. Minus 3 over 4. And this is going to be minus 1 upon 2. Uh, So let's add the two terms and see what is the answer. I'm going to calculate for you. It's negative 3 by 4, negative 1 by 2. That gives me, so dy over dx will be minus 1.75. This is my final answer. So yes, in this question, the key thing is Your term should be in separated form. Then you can differentiate. Okay, please note it carefully. Okay, let's check on the next question number 2. Find the gradient of the curve. Okay, the gradient of the curve means we have to differentiate. Yes, no doubt at all. Yes, we have to differentiate, but for differentiation, the bracket should be expanded. So let's expand the bracket, simplify them, and then differentiate. So let's start the expansion first. Now 2x times x gives you 2x squared. 2x times 4 gives you 8x. Minus 5 times x is negative 5x. And minus 5 times 4 gives you negative 20. Let's simplify. It's going to be 2x squared plus 3x minus 20. Now we differentiate this x equation with 2 times 2 times 2 minus 1. 3 times 1 x power 1 minus 1. Negative 20 is a constant, therefore the derivative will be 0. So your dy over dx is going to be 4x x power 0. Yes. X power 0 means what? The final answer is 3. Okay, so we have completed two tasks. First thing, we expand the brackets. Secondly, we differentiate the equation. Now, the final thing is substitute the value of x to get the value of dy upon dx. So dy over dx will be 4 times 3 plus 3. 12 plus 3. So your dy upon dx will be, that's our final answer, the final differentiation. Please note it carefully. Okay, then move on to the next question. Yeah, that's question number 3. Find the value of dy upon dx. Okay. In this question, what we found different? Yes, look at the equation. In the all previous equation, we found y as subject, but in this equation, there is no y as subject. So first thing first, let's make y subject. Okay. So it's going to be y is equals to 12 divided by x. We made y as subject. Now, for the differentiation, x should be in numerator. So let's shift this new x in the numerator. and this becomes -1. Now we differentiate the equation. It's going to be 12 times -1. Or not this. -1, -1. Yes, now that's fine. So dy over dx is equals to -12 x power -2. Now bring down this power, which is -2, and it's going to be x squared. So 2 -12 over x squared. This is your dy upon dx. But you are looking for the value of dy upon dx. That's why we substitute the value of x. That's 2 squared. Yes. So dy over dx going to be -12 over 4. Therefore, dy over dx this is the way we find dy upon dx. Yes, please. Note it very carefully. So we move on to the next question. Let's see what we have in the next question number 4. The gradient of the curve. Yes, gradient of the curve is given, which is 5. And they asked me to find the values of a and b. Remember, there are two missing things, a and b. Therefore, we must have two equations to solve or to find a and b. The question is how we are going to form these two equations. Very first thing is, look at this point. This point lies on this curve. Therefore, I can substitute y as -3 and x as 3. By doing this, we will get an equation in terms of a and b. So this is -3, this is 9a, and this is 3b. Let's divide the whole equation by 3. This is the very first equation. I need to write again. So I divide whole equation by 3. It's going to be 3a plus b. I'm going to make b as subject. So b is going to be -1 -3a. Now, we need one more equation. And they gave you a gradient. Gradient, yes, means they have given you the value of dy upon dx. Yes. Means we have to differentiate the equation first. Remember, a and b are treated as constant. So dy over dx. So a times 2 power 2 minus 1. Secondly, we have b with power 1, 1 minus 1. plus bx power 0. The final dy upon dx would be 2ax plus b. But they gave you a gradient which is 5, means the value of dy upon dx is 5. At which point 3, negative 3. So let's substitute 3 in the equation. And I substitute x as 3, 5 as the green, they gave you gradient. So 5 plus 6a plus b. Now replacing b with the value. So 5 plus 1. So 3a equals 6 and a will be, okay, give it. Uh-oh. So a is going to be to this as the value of a. Second thing, t. So we substitute, oh, remember this, please. Oh, it's minus 1 minus 3 times 2. So b is equals to minus 1 minus 6. So b will be minus 7. Please note it down. Let's move on to the next question. Yes, we have differentiation with brackets. So let's see how we differentiate in case of brackets we have. Yes, we have a bracket here. So let's differentiate. Again, the basic rule is first bring down this power 6. But remember, bracket will not be changed. Your bracket will remain same. Only power, we subtract 1 from the power. That's called first part of bracket differentiation. In the second part, we draw another bracket and differentiate this part of bracket, which is x. And the rule of the differentiation, as you know, bring down the power and subtract 1 from the power. Now we differentiate the second part of the, so we differentiate the constant. Yes, that's going to be minus that plus 0 because we differentiated the 4. Let's simplify. It's going to be 6 bracket x plus 4 power 5. In the bracket, it's going to be x power 0, which makes 1. Therefore, your final answer will be 6. This is how we differentiate the equation or the bracket differentiation. Then let's try another one. That's part B. As you can see, the part B, again, we have a bracket here. We follow the same method of the differentiation. First thing first, we bring down this power and the bracket. The anything inside the bracket will remain same. Then we subtract 1 from the power. That's the first part of differentiation of bracket differentiation. In the second part of this differentiation, we draw another bracket and differentiate the first part, which is 2x. We follow the same rule as we did in the previous part. The last thing is 3. 3, since it's a constant, the derivative will be 0. This is 8. This is 2x. This is 3 power 7. And this is going to be 2x. So the final answer will be, so dy upon dx will be dy over dx is going to be, now look at this. This 2 will multiply by 8. That makes 16. And this is 2x plus 3 power 7. Yes. This is your final answer of differentiation. So let's take the part C. Yes, we have a square root here. And as you know, the square root means the whole power is 1 over 2. Right? This is what we know about the square root. Rules are same. Rules are not going to change for anything. So bring down this power 1 upon 2. Inside the bracket, all stuff remains same. Then we subtract 1 from the power. Then we differentiate this part inside the bracket in other bracket. So 2 times 2x power 2 minus 1. That's the first part of the bracket. And this is the second part of the differentiation, which is 0. So 1 over 2 x square. I told you the bracket inside the bracket remains same. It's going to be negative half. Now we differentiate this. We have differentiated this part. It's going to be 4x power 0. It's 1 over 2, 2x square minus 1 power minus half, and this is 4. This 2 and this 4 now cancels. Secondly, I bring down this bracket in the denominator because the power is negative. It's 2x square minus 1 power positive half. But if you want to, which is not necessary, what you can replace this power half with square root again, like this. Okay, let's take the next part D. Again, we have a square root here, means this term can be expressed as x cubed minus 5x and the power is half. First thing first, bring down this power and the stuff inside the bracket will remain same and subtract 1 from the power. Then whatever we have inside the bracket, we differentiate 1 by 1. So starting with the x cube, it's going to be 3x3 minus 1. Then the second term is, if you look at 5x carefully, the power of x is 1. Be careful. So it's going to be 5 times 1 x power 1 minus 1. Bracket close. Now, it's 1 over 2. This is 5x. And the power is minus half. In the second bracket, we have 3x squared minus 5x power 0. Now you can see the minus half power. Let's bring it down, make it positive. So 3x squared minus 5x, and this is 2x cubed minus 5x. And its power half. And the last thing, we are writing down the denominator in the square root again. This is our final answer of the differentiation. That's our answer for the part D. Yes. Now we're moving on to the part E. In the part E, we have and the square root, but there is a difference, and the square root we have in the denominator means we have to bring in the numerator as well. So let's go for it. It's going to be 1 over 2x minus 5 power half, or I can write it as 2x minus 5 power minus half. So start differentiation, let's bring down the power first, then subtract 1 from the power, then differentiate whatever we have inside the bracket is 2 times 1, it's 1 minus 1. Minus 5, yes, constant, the derivative becomes 0. So minus 1 over 2, 2x minus 5 power minus 3 upon 2, and this is 2x power 0. So this 2 and this 2 may cancel, we have 1, and we're shifting down this in the denominator, it's going to be minus 1 over 2x minus 5, it's 3 upon 2. Now, there is a possibility I can write, but again, I tell you, it is not necessary that you express in this form. And the result I can write here is 1 over square root 2x minus 5 whole power 3. This is one of the way of expressing this answer. But again, I tell you, there is no need to take a stress for this. Yes, please note it carefully. Let's end our class here. Inshallah ta'ala, we will be here very soon again for some more interesting video regarding the differentiation and the integration as well. In a day or two, you will see some more interesting and beneficial videos. Thank you very much. Till then, take care and Allah Hafiz.